Why is the Carnot cycle important for heat engine efficiency? Imagine a machine that can convert heat into work with perfect efficiency. Sounds like science fiction, right? Well, the Carnot cycle is a theoretical model that shows us the maximum efficiency any heat engine can reach. It sets the gold standard for how well engines can perform when transforming heat into useful energy. This cycle helps engineers understand the ultimate limits of engine performance and guides the design of real-world machines. The Carnot cycle is made up of 4 steps: to our isothermal processes where temperature stays constant, and to our adiabatic processes where no heat is exchanged. Because all these steps are reversible, there are no losses like friction or heat leaks. This makes it an idealized, perfect cycle that no real engine can fully match. Still, it's very important because it tells us what the best possible efficiency is based on the temperatures of the heat source and sink. The efficiency of a heat engine depends on how much of the heat energy it takes in can be turned into work. The Carnot efficiency formula is simple: 1 minus the temperature of the cold reservoir divided by the temperature of the hot reservoir, both in Kelvin. This means that increasing the temperature difference between the hot and cold reservoirs makes the engine more efficient. But it also shows that no matter how good the design, real engines will always fall short of this ideal because of unavoidable losses. This cycle is a key part of the second law of thermodynamics, which states that some energy will always be lost as waste heat. It proves that 100% efficiency is impossible, but it also provides a target for engineers to aim for. By understanding the Carnot cycle, engineers can improve engine designs, choose better materials, and operate at higher temperature differences to get closer to this ideal. In practical terms, the Carnot cycle acts as a benchmark. It helps us compare real engines and see how much room there is for improvement. For example, power plants and engines can be designed to operate as close as possible to the Carnot efficiency by maximizing temperature differences and reducing losses. Although no engine can reach this perfect cycle, knowing its principles helps us push the boundaries of what's achievable. In short, the Carnot cycle is important because it defines the maximum efficiency limit for heat engines. It guides engineers in designing better machines and explains why some energy is always lost. By understanding this cycle, we can develop more efficient engines and better understand the fundamental rules of energy conversion.